Hello everyone, welcome to Rasaayana Institute of Sciences. In this video, we are going to discuss about what are Iupac rules, how these rules are helpful to select a functional group skeleton as well as organic skeleton, and even without functional group, without organic functional group skeleton, everything will be discussed clearly over here. Okay, so generally Iupac rules following some generalized conditions, and by following that generalized condition one can give name of an organic molecule very easily. So in that first one is longest carbon chain. Longest carbon chain rule. So what is the longest carbon chain rule and how it is going to be helpful for selection of a parent chain? So generally in order to select a parent chain, see, this is mostly helpful for selection of a parent chain. It is used for selection of a parent chain. So what is a difference between parent chain and simple chain? So the carbon chain which having more number of carbons in a given skeleton, or whichever direction it may be a straight chain or zigzag chain. So the hydrocarbon chain which carry more number of carbons. So here I am taking a carbon chain which carry more number of carbons. Okay, so this particular carbon chain is nothing but a parent chain. So this is also called hydrocarbon chain. Hydrocarbon chain. So now this hydrocarbon chain, also known as parent chain, these two will be get differentiated very easily. Simple chain and parent chain I am saying. So a normal carbon chain which having more number of carbons, that is said to be a hydrocarbon chain, also called derivative of hydrocarbon chain, also called one more parent chain. So if you want to give nomenclature of any organic molecule, you should be very strong in selection of parent chain. So once if you know the parent chain selection, numbering will be very easy for you. So what is a parent chain? Which carry more number of carbons in a longest part of skeleton, that is called parent chain. And this parent chain carry straight chain, it may be a zigzag chain. Okay, it may be a straight chain, parent chain may be a straight chain or zigzag chain. So don't think that parent chain means always it becomes a straight chain. Next, see, I am taking a selective example. See, in this case I am using a variable number of carbon skeletons without hydrogens I am writing. Total number of carbons are 1, 2, 3, 4, 5 is there. And if you go any direction 1, 2, 3, 4, 1, 2, 3, 4, so no other direction carry more number of carbons. Now this may be a parent chain. Hydrocarbon chain also called parent chain. Now I am taking one more example, 3, 4 and this is 5, and if you observe this clearly, 2 carbons I am giving and here also I am giving 2 carbons. Select a longest carbon chain which carry more number of carbons. So based on that statement I can select this 3, 4, 5 and this is 6 like this. 1, 2, 3, 4, 5, 6, 7. 7 carbon chain is a parent chain. Okay, so that is a selection of a longest carbon chain. Everywhere if you select a longest carbon chain, that longest carbon chain is said to be a parent chain. Okay, next, after go for carbon functional group selection. Carbon functional group rule, otherwise selection or rule. What is this carbon functional group rule? See, according to the first rule, try to select a carbon chain which carry more number of carbons. That is this rule is saying. But this rule is saying that select a parent chain which is starting from a carbon functional group. So maybe other direction may carry more number of carbons, other direction may carry parent chain, looks like parent chain, but that rule, this rule will be violates if carbon functional groups are present. Okay, so now especially for this one, see, select a parent chain. We need to select a parent chain from carbon functional group. Carbon functional group. So we need to select a parent chain from the carbon functional group. Okay. So what are the available carbon functional groups are present? So I can take cyano. You can take even aldehyde is a carbon functional group. Then we can also take keto. Then carboxylic acid. And carboxylic acid derivatives such as esters. Then we can take acid halides, amides and even anhydride. C double bond, O, C double bond O like this. So these all are called carbon functional groups. So whenever if these carbon functional groups are present, try to select a parent chain which is starting from this carbon functional groups. You will understand by taking one example. So whenever if these functional groups are available, don't follow longest carbon chain rule. Because here parent functional group will decide the selection of a parent chain. Here functional group is present, especially carbon functional groups. Carbon functional groups are nothing but, you can remember, these are a carbon functional groups. Here carbon consisting species. So these all are called carbon functional groups. So carbon should carry lowest number. Okay, if this kind of groups are present anywhere, try to give or try to select a parent chain from this particular functional groups only. Okay, now see next. How to write a parent chain with respect to this one. See, this is one selective molecule. Here aldehyde I am giving here 2 carbons. Now here I am giving 2 more carbons. Generally, how to select a parent chain? Now generally, if you consider only carbons which are belongs to parent chain, on that time you will select like this 1, 2, 3, 4, 5, 6, 7. But that is wrong. Always when carbon functional group is present, try to select a parent chain from carbon functional group only. This is a carbon functional group, select from here. I can write 1, 2, 3, 4, 5 and this is 6. That is a selection of parent chain. So this is a parent chain now. This is parent chain of this molecule. Okay. So you can take one more example. Here I am writing carbon nitrile. So here carbon carbon double bond, here carbon carbon like this. So maybe other direction carry more number of carbons, that direction should not be considered. See this side carbon nitrogen, nitrile is present. Nitrile is a carbon functional group. It is a carboxylic acid derivative. Try to give numbering from this carbon. So 1, 2 and this is 3, 4 and this is 5, 6 and this is 7. So irrespective of the direction, other direction. See if you consider this side, more number of carbon chain is present, but that is not a parent chain. But if you consider this side, we are starting numbering or we are selecting a parent chain from carbon functional group. So this second rule is applicable only when carbon functional groups are present. Suppose if any other than carbon functional groups are present, such as hydroxy, thiol, mercaptans, and if you can go for any other alkoxy derivatives, amine derivatives like that, on that time this rule can't be applicable. So try to remember carbon functional groups starting from aldehyde, ketone, ester, acid, whatever it may be, that all are belongs to carbon functional groups. If carbon functional groups are given, try to give numbering from that carbon functional group, carbon only. That will carry always number 1. Okay, so you need to start from here only. So start from here, keep going toward that side where you will get more number of carbons. See, I can write like this. So this is a selection of parent chain, and remaining to this parent chain, there belongs to substitution. This is substitution, substitutions we are going to use at second grade functional group, secondary prefix. This is secondary prefix, secondary prefix, secondary prefix. These all are secondary prefix. So you can understand secondary prefix or you can identify secondary prefix only when if you know the parent chain. So the groups which are attached to parent chain, that all are called substitutions, also called locants, also called secondary prefixes. Okay, these all are secondary prefixes or substitutions you can say. Okay, so that is about carbon functional group rule. So try to select a parent chain which carry more number of carbons if there is no carbon functional group. Suppose if any carbon functional group is present, select a parent chain which carry carbon functional group, and from particular carbon functional group select a longest carbon skeleton. Okay, so that is this one. Then go for third rule, numbering of longest chain. Numbering of longest chain. How to number a longest chain? So up to now we discussed only one point, how to select a parent chain. 2 selective points will be there. Now third one, after selection of a longest chain or parent chain, it is also called parent chain, then how to give numbering? So numbering of longest chain or parent chain, it depends on substitutions only. This is called substitutions. It depends on substitutions, also called locants. They are also called locants or second grade functional groups. So suppose if longest chain having no substitutions, you can give numbering from any direction. See, this is the longest chain. I can give numbering in any direction. I can start from here 1, 2, 3, 4, 5, 6. You can give numbering from any direction if there is no substitution. But suppose if any substitution is present, try to give select a direction. After selection of a parent chain, select a direction where substitution carry lowest number. Okay, so here we need to remember always substitution get lowest number. Okay, that direction we need to select. Always substitution get lowest number. Suppose see, this is one skeleton, here I am writing one substitution. Try to select a parent chain. I am selecting parent chain from this side. Okay, this is one direction. 1, 2, 3, 4, 5. It is a parent chain. After selection of a parent chain, you may get one question in your mind. Sir, why you are not selecting from left to right? Is it possible to select only from right to left, or only left to right is also possible? So generally only right to left is possible, because see, if you give numbering from this side, substitution present at second position. But if I give numbering from this side, 1, 2, 3, 4 and this is 5. Substitution carry number 4, means it is highest number. So this is the correct direction, it is a wrong direction. Always select a direction in which substitution carry lowest number. That is the first possibility. Okay. So if any substitutions selection of longest chain, if any carbon functional group is present, this rule cannot be applicable. If any carbon functional group is present, try to give numbering from carbon functional group only. Okay, I will give that example, you will understand clearly. Okay, so here only I will give. See, here if I give one substitution, and here I am giving a carbon functional group here. Now, so generally if I start numbering here, you will get number 2 for substitution. And see, this is a parent functional group. Select a carbon functional group, that is 1, 2, 3, 4, 5, 6. On 5th carbon substitution is present, but if you give numbering from left to right, second carbon substitution is present. If I start numbering from this side, 1, 2, 3, 4, 5 and this is 6. So below direction, this direction is not correct. Only above direction is correct. This side means 5, 1, 2, 3, 4, 5, 6. This number is correct. So this is completely based on carbon functional group only. So that's why try to identify carbon functional groups clearly. If any carbon functional group is given, that should be taken as 1. And irrespective of the position of a substitution. Okay, that is the first one. Next, go through fourth one. Next rule, lowest sum rule. What is lowest sum rule? How it is going to be helpful? Lowest sum rule is nothing but, see, selection of a parent chain also depends upon the substitutions. So select a parent chain direction where substitution carry lowest number. So you will understand by taking one example. So here I am writing direct point. C. Select a parent chain having lowest sum of locands. Lowest sum of locands. Lowest sum of locands also nothing but substitutions even. Lowest sum of locands and substitution both are same. So what is this rule is saying? See, if more than one substitution is present, here one substitution is present. If I give numbering from here 1, 2, 3, 4 and this is 5. Now, what is the position of substitution? 2 and 3. So this 2 and 3 is equal to 5. This is possible. Next, one more direction. If I select from here 1, 2, 3, 4, 5. Now see, 3 and 4 you will get. 3 plus 4 you will get, that is 7. So this is correct and this is wrong. Always select a number which should be always lower. Only that direction is correct. So I can say 2, 3 dimethyl pentane. That is an example. Okay. Next. Now it may be any kind. Suppose here ethyl and methyl is present. Your numbering is like this only. 1, 2, 3, 4 and this is 5. Both are same. This is the correct direction. Don't give priority from this side. Okay. So it may carry 2 identical substitution or non-identical. Your answer is remain same. If I start numbering from here 1, 2, 3, 4 and this is 5. 2, 2 dimethyl pentane. Okay. It may be identical or non-identical. It may be straight or zigzag. Anything is possible. Always substitution carry lowest number. if multiple substitutions are present. Now this is the most important one. See, if two different substitutions are present, suppose here both are two methyl groups here methyl both are present. You can give numbering from either right side or left side, because both directions you will get 3, 4. But what I am saying is, suppose one is methyl, other is ethyl. Sum of locands are same. See, if I give numbering from this side, 1, 2, 3, 4, 5, 6. If I give numbering from right to left, third position, fourth position carry locands. 3 plus 4 is equal to 7. And if I give numbering from below direction, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So here also see 3 and 4. These two numbers you concentrate. 3 plus 4 here also same. So this is sum of locands are same in this case. Sum of locands are same, and in this case also sum of locands are same. See, when sum of locands are same in both directions, locands also nothing but substitutions. If sum of substitutions are same in both directions, select a direction, we need to follow alphabetical order. So during that particular selection, especially alphabetical order for substitutions. See, if sum of locands are same, then only this rule is applicable. Left side is 3 plus 4, right side is also 3 plus 4. On that time, select a longest chain in which substitution follow alphabetical order. See, this substitution carry ethyl. This is ethyl. This is ethyl, and this is about methyl. Ethyl, methyl both are given. Ethyl start with E, methyl start with M. So I can say E is first as compared to M. Follow alphabetical order of locands. So this is the correct direction. 1, 2, 3, 4 is the correct direction. This is wrong direction. So I can say every substitution, every locand follow alphabetical order while writing Iupac nomenclature, and that is well known. So I can say 3 ethyl, 4 methyl, then followed by hexane. Like that you should write. This is applicable when sum of locands are same in both directions. Suppose if sum of locands are not same in both directions. See, 3, 4, 5, 6, 7. 7 carbons are given. Now, here I am giving ethyl and here I am giving methyl. In this ethyl, we are selecting this side. But see, first you see whether sum of locands are same or not. Sum of locands are same, then only apply alphabetical order of locand, starting letter. But if sum of locands are not same, see, I am starting from here 1, 2, 3, 4, 5, 6, 7. So 4 plus 5. 4 plus 5 you will get 9. And if I start from here 1, 2, 3, 4, 5, 6, 7. Okay, so now here 3 plus 4 you will get 3 plus 4. Now you will get 7. So after getting this, lowest number is 7. Here highest number is this. This is not applicable. But here see, both directions you are getting same number. So that's why follow this side. So I can write directly from here. This is correct way of giving numbering. But write down Iupac name according to alphabetical order. So third position carry methyl. Don't write 3 first. Write down 4. So I can write like this. 4. This is ethyl. 4 ethyl. And this is 3 methyl. Then finally, total number of carbons are 7. I can say heptane. This is the name. Okay, Iupac names are one word names. Don't give any space between complete Iupac name of a molecule. So between two words, don't give any space. Actually, for your understanding purpose, I give any space, but don't try to give any space between two words. Okay. Now, next. After lowest sum rule, if you find a more than one different substitution, this is a strategy. So sometimes what happens, see, they will give a multiple disorder substitutions. Multiple disorder substitution means, see here, I can write 1, 2, 3, 4, 5, 6, 7, 8 I given. Now, here I given ethyl and here I am giving a methyl here. Now which direction you will select? This is called first point of difference rule. According to first point of difference rule, select a direction where substitution always get lowest number. Which is substitution here? Ethyl is a substitution, one more is methyl. If I select from this side, 1, 2, 3, substitution carry number 3. If I select from this side, 1, 2, 3, 4, 5, 6, 7, 8 and this is 9. 9 carbons are present. Substitution carry number 2. So always give high priority for that particular direction of a parent chain where substitution carry lowest number. Lowest number is 2. So I can say directly this is 3 ethyl First alphabetical order, 3-ethyl, then 2-methyl, total number of carbons are 9, so I can say nonane. That is the answer. So that is called lowest sum rule. So 2 points you need to remember for lowest sum rule. Select a longest carbon chain in which sum of locants should carry lowest number. It may be similar substitution or dissimilar substitution. Suppose if sum of locants are same in both directions and substitutions are different, on that time we need to select a parent chain such a way that substitution starting letter should be follow alphabetical order. Means we need to follow alphabetical order for substitutions while giving nomenclature. And here also same, a dissimilar selection I given with respect to this. So generally don't think that ethyl and M, both letters are, if you compare alphabetically, ethyl will come first. That's why I am not giving this. First is lowest sum rule. If lowest sum rule is coincide, then only follow alphabetical order for locants starting letter. Or locants you can say simply. And here also same. So generally for your general analysis I given one from right side, other from left side. If I start from right side, you will get 3 and 4. So here lowest sum is 7. Lowest sum is not coinciding. When lowest sum coincide, then only follow that rule. Clear? So but always write down Iupac name. Start with a lowest alphabet, then going for highest alphabet in case of substitutions. That is lowest sum rule. Next. This is unsaturation rule. According to unsaturation rule, we need to select a parent chain which carry maximum number of double bonds or triple bonds. So what is unsaturation rule is saying? Select a parent chain which carry more number of unsaturations. Unsaturation is nothing but double bond or triple bond. So here I am selecting one example. See, this is double bond and here one more double bond and here I am giving more number of carbons. If you see in this molecule 1, 2, 3, 4, 5, 6, 7 carbons are present. But if you go this side 1, 2, 3, 4, 5 only. So what I am saying is when any skeleton carry double bond or triple bond or multiple bond, that is called unsaturated rule. This rule is saying that try to select a parent chain which carry more number of double bonds. So according to that we need to select this one. Even though other direction may give more number of carbons, that is not going to be considered. That is called unsaturated rule. Okay. So this molecule name 1, 2, 3, third position carry 1, 2, 3, 4, butyl. So 3 butyl or 3 N-butyl followed by 1, 2, 3, 4, 5, 1, 5 pentadiene. So that I will explain later names. In this rule only it will come. Okay. Now see, when molecule carry more than one double bond or if any substitution and double bond both are present, remember always give priority for double bond only because double bond is a functional group. If double bond substitution both are present, give priority for double bond. So I can give like this 1, 2, 3, 4, 5. So I can write directly 4 methyl and write down the position of double bond. Double bond present at 1. So 1 it is pent-ene. Here ene indicates a double bond. So here we are not giving priority for substitution. We are giving priority for double bond because double bond is a functional group. Okay. Next. So it may be anywhere. First you need to give priority for double bond only. See here 2 substitutions may be present. You need to give numbering from double bond only. So whenever double bond present middle, don't start directly from here. You try to start tail or ending point. This is ending point 1, 2, 3, 4, 5, 6. So what is the Iupac name of this molecule? 5, 5 dimethyl. 5, 5 dimethyl. Double bond present at second position. So write down 2. Total number of carbons are 6. So I can write hexene. That is the name. 2 hexene. Otherwise hex 2-ene. That is also acceptable. Okay. So suppose if molecule carry multiple double bonds, 2 double bonds are present. Now you need to give numbering. Finally numbering is most important, 3 and 4. Now in this case total number of carbons are 4. So write but and add letter A. If more than one double bond is present or triple bonds are present, add letter A. Buta. Buta 1, 3 diene. So I am writing position of double bond here, position of double bond here. only starting point of double bond should be considered. 1 and 3 are starting points of double bond. That's why I'm saying 1, 3 butadiene. Okay. Suppose if triple bond is present. Now same 1, 2, 3, 4. Buta 1, 3 diene. Diene now it becomes a diene. So buta 1, 3 diene. If any substitutions are present in this case, you can write like this. See, first you need to select a longest carbon chain. This is the longest carbon chain and here one substitution is present. If I start numbering from here 1, 2, 3, 4, 5. Don't select right side, select from left side because substitutions and functional loops carry lowest number. First functional loops. Carbon-carbon double bond is a functional loop. Select from this side. 1, 2, 3, 4. So fourth position carries substitution. I can write 4 methyl. 1, 3 here pentadiene. That is the answer. If more than one double bond is present, add letter A, penta. This letter is most important. Penta and here also buta. Okay. So this is most important one. Remember when double bond, triple bonds are present, always try to give numbering from double bond. Iupac name ends with triple bond. Numbering start from double bond, Iupac name end with triple bond. If this is possible only when if both are at terminal. So I am writing but 1 ene then followed by 4 ine like that. We are giving lowest number for double bond and Iupac name is ends with triple bond. That is a condition. That is a rule. This is applicable when both are at terminal. Suppose if double bond is at internal, if triple bond is at terminal, we need to give numbering from triple bond only. 1, 2, 3, 4 and this is 5. But name ends with triple bond. Now in this case I can write pent then followed by 3 ene then 1 ine. Always remember whichever is a terminal, it may be double bond or triple bond, from that particular direction we need to start give numbering and always Iupac name end with triple bond. So in this case both are a terminal. I am starting from double bond, Iupac name end with triple bond and here see one is internal, other is a terminal. So whichever is terminal, from there we need to start numbering. So even in case of this we can apply the same way. See, internal triple bond is present, terminal double bond is present. Whichever is terminal, from there we need to start numbering. 1, 2, 3, 4, 5, 6. Total 6 carbons are present. I can say C hex. Don't write hexa. Hex only hex. Then followed by 1 ene. Then followed by 3 ine. Like this. If double bond, triple bond are present at terminal, whichever side terminal double bond is present, from there we need to start numbering. Terminal. It is terminal. It is also terminal. Suppose if double bond internal, triple bond is terminal. So whichever is a terminal, from there we need to start give numbering. So now triple bond is a terminal. That's why I'm starting from here. In this case, double bond is a terminal. I'm starting from right to left. That is the case. See, I'm taking a molecule in which 2 double bonds and 1 triple bond is present at middle. Now you can start numbering from here. 1, 2, 3, 4, 5, 6. Total 6 carbons are present. But double bond positions are 1 and 3. These are the double bond positions 1 and 3. So 1 and 5 are double bond positions. 3 will be triple bond position. So now you can say like this. This is hexa. I am writing hexa because 2 double bonds are present. Hexa 1, 5. 1, 5 diene. Don't write ene. Only en you should write. Diene. Then end with 3 ine. Diene 3 ine. Suppose if 2 triple bonds are present, 1 double bond is present. Now I can start numbering from like this. 1, 2, 3, 4, 5, 6. Now what is the position of double bond? Third position. So I can write hex 3 ene. Hex 3 ene. Then this is 1, 5 diene. That is the name. Almost all same numbering. Okay. Now suppose if I take any cyclic ring, this is called cyclohexane. Suppose if any substitution is present, methyl, I can say methyl cyclohexane. Now there is no numbering is required here if only one substitution is present. Suppose if two substitutions are present, definitely numbering is required. See this. This is 1, 2, 3, 4, 5, 6. I can say 1, 1 dimethyl. 1, 1 dimethyl cyclohexane. Okay. If two different substitutions are present or two different positions, I am saying. So I can say 1, 2 dimethyl cyclohexane. Suppose if two different substitutions are present here. See, this is ethyl and this is methyl. This is 1. So 1, 2, 3, 4, 5, 6. I can say 1 ethyl, then 2 methyl. 2 methyl cyclohexane. 2 methyl cyclohexane. Suppose if 2 ethyl and methyl both are opposite side, means adjacent carbons, opposite side, same side, that I will explain. Now, this is 1 and this is 2. Don't give below to above because sum of locands are same. On that time, substitution starting letter, alphabetical order we need to follow. So I can say 1 ethyl, 2 methyl, 1 ethyl, 2 methyl cyclohexane. Okay, but whenever if there is a presence of double bond is present, now molecule carry double bond. So this is double bond, and see, when double bond is present, always give directly name from double bond only. So this is a starting point, cyclohexene. Suppose if any substitution is present here. Now first you need to complete double bond here. 1, 2, 3. First you complete double bond. Don't complete substitution. So first you should say 3 methyl. 3 methyl cyclohexene. Here don't say 1 hexene because this 3 comes from this double bond position only. Even if you write 1, nothing will happen. Okay. Suppose see, this is a double bond, this is substitution and this is methyl. So from where you will give numbering. See, first you need to complete double bond with two lowest numbers. Okay. Suppose if I start numbering from here 1, 2, 3, 4, 5, 6. 1 coming from double bond, but 6 coming from substitution. Okay. So if I start numbering from here, 1, 2, 3. So double bond carry always 1. That's okay. But substitutions carry 2 and 3. Substitution carry 2 and 3. So first substitution carry 2, second substitution carry 3. Suppose if I give numbering from this side, 1, 2, 3, 4, 5, 6. Same double bond carry 1, that is acceptable. First substitution carry 2. Now this is correct. Means lowest number for substitution. So I can say 1 methyl, or we can say 1, 6 dimethyl. Both are identical. We can write 1, 6 dimethyl cyclohexane. Excuse me. So don't give numbering from here 1, 2, 3. So generally you people think that covering double bond is a first priority. Okay, that is first priority, but if I give numbering from here 1 and 2, 1 carry double bond, but there is no substitution. But here, if I give 1 carry double bond, no substitution. If I give 1 here, 1 carry double bond as well as substitution. Lowest number is both for functional group as well as substitution. That is correct order. Okay. So that is an example for unsaturated rule. Suppose if multiple double bonds are present, we need to follow like this, or same. This is multiple double bond 1, 2, 3, 4. Okay. So cyclohexa 1, 3 diene. Cyclohexa 1, 3 diene. Now if any substitution is present like this, this is ethyl and this is methyl. This is most important one for your examinations. So two numberings, just now whatever the example I explained, based on this we need to give the numbering. So if you understand clearly, you will give the answer. See, don't give numbering from here. See, this is 1, 2, 3. This is wrong numbering. But if you start from here, 1 carry double bond. Here also 1 carry double bond. But next one substitution is also there. But here 2 carry substitution. Now substitutions will decide the answer. Now this is 1, 2, 3, 4, 5, 6. Don't go this side. First you complete double bond. So now it is 1, 6 is correct. Okay, so I can write, this is the correct way of numbering for this molecule, but not this one. So I can write 1 ethyl, 6 methyl, 1 cyclohexane. That is the name. Okay, then last rule. Branching rule. What is this branching rule? How it is helpful? So generally these points are well known, I think so. Suppose if two identical substitutions are present, the two identical substitutions will be represented as di, tri, tetra, etc. Okay. So branching rule is saying that try to select a parent chain in which we need to reduce branches. So always reduce branches here. Reduce branches. So you will understand by taking example what is a branch. Always reduce branches in parent chain. Parent chain, try to reduce branches and try to increase substitutions. If any substitution carry one more substitution, that is called branch. Okay. So try to reduce branches and try to increase the substitutions. So during this particular process, if more than one branch is present, so we need to use the letters bis, tris, tetrakis, etc. Tetrakis, pentakis, like that we need to use. So more than one identical branches. For identical substitutions, we need to use a di, tri, tetra, etc. But first condition is, remember, for branching rule, try to remember, try to reduce branches, try to increase substitution. That is the first condition. Okay. So here I am going to take one example. See, this is a branch. Remember, it is a parent chain. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. This side 7 carbons are present. This is a parent chain. 1, 2, 3, 4, 5, 6, 7. This is not a substitution. Now it is a branch. You can also use isopropyl. That is also considered. But generally it is considered as a branch. Now, after selecting a parent chain, now branch, I can write like this. 1, 2. Branch, we are giving numbering in the form of 1 dash, 2 dash. Now try to select the position of branch. Where it is present? At 4. So I can say 4. Then 1 dash. 1 dash carry methyl. 1 dash, 1 dash methyl, and here longest chain carry 2 carbons. I can write ethyl. Ethyl, total number of carbons are 7. I can write heptane. Okay, that is a way of selection. So don't think that if this kind of substitutions are present, always they are belongs to branches. Sometimes it may be a substitution if you see properly. See, this is a molecule. How many branches are present? So target is try to reduce branches and try to increase substitutions here. If I start numbering from here, 1, 2, 3. 1, 2, 3. So 3 carry methyl, 3 carry ethyl. So new better is this one. 1, 2, 3, 4, 5, 6. Now no branch is there, all are substitutions. So your target is to reduce branches and target is to increase substitutions. If there is no other alternative, if one of the direction, if you are getting a parent chain, on the time blindly this will be a branched chain. Okay. Now I can write 1, 2, 3, 4, 5, 6. Now third position carry ethyl. 3 ethyl. 4 and 5 position carry methyl. Even second position also carry methyl. So I can say 3 ethyl. 2, 4, 5 trimethyl hexane. That is the answer. Next, if you see this example clearly, now this is a branch and here one more branch I am giving. These all are branches, because you can reduce branches only when if you get the substitutions with more number of substitutions. See, first you select a parent chain. See, I am selecting parent chain from this side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 carbons are there. Any other direction you will not get 10 carbons. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Like that. You take any direction, you will not get 10 carbons. So blindly, this side we need to start numbering. 4, 5, 6, 7, 8, 9, 10. Okay. So here I am writing fourth carbon, one branch, fifth carbon, one more branch is there. So I can write 1 dash, 2 dash, here 1 dash, 2 dash, and this is 3 dash. Okay. So fourth position, now one branch is present. So that is 1 dash methyl, and here it is ethyl. 1 dash methyl ethyl. Then one more branch is there at 5. 5 carry 1 dash methyl. 1 dash methyl, 1, 2, 3. 3 carbons are present. So 3 carbons means propyl. Then total number of carbons are 10. When 10 carbons are present, your answer is decane. That is the answer. So remember, always your target is to select a longest chain which carry more number of carbons. After selection of longest chain, if any substitution carries somewhat additional substitution, they are called branches. So during selection of a parent chain, it looks like a branch. If you select properly, that branch becomes a substitution. If alternative is not there, then that substitution becomes a branch. Here that is the case. See, if I reduce like this, then this all are becomes a branches, but that is not a proper selection of a parent chain. Remember, proper selection of parent chain is mandatory. So one more example I will give with a identical substitutions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here I am giving isopropyl, and here also isopropyl. Remember, this is also termed as isopropyl even. But better you practice with a branch. Now, 4, 5, 6, 7, 8, 9, and this is 10. Fourth carbon carry one branch. Fifth carbon also carry one branch. I can write it as 1 dash, 2 dash, 1 dash, 2 dash, 1 dash methyl, ethyl. Now the question is, fourth position and fifth position carry identical branches. So now we can write like this. So first we need to start with bis. Bis 4, 5. We need to write like this. Bis because two branches are identical. Bis 4, 5. I can write 1 dash methyl ethyl. 1 dash methyl ethyl, and total number of carbons are 10, so I can say it is decane. Okay, so that is about branching rule. That is about few examples on branches present in a parent chain. Okay, just make a short revision of this all concepts. See this. So what are Iupac rules? How these Iupac rules are helpful for determining the name of an organic molecule. First rule is saying that longest carbon chain rule. According to this rule, select a parent chain which carry more number of carbons. That parent chain may be straight chain or zigzag chain. Okay, then it may be a straight chain or zigzag chain. Don't think that parent chain is always a straight chain. It may be straight or zigzag. Carbon functional group is saying that whenever any organic molecule carry carbon functional groups, these all are called carbon functional groups. Aldehyde, ketone, ester, acid ester, acid halides, amides, anhydrates, and this is called nitrile. If these functional groups are present anywhere else in a given organic molecule, try to give numbering from that organic functional group only. Lowest number should be given for that carbon functional groups. Means indirectly I am saying that try to start numbering from these carbons. This is called carbon functional group rule. So see, I am starting from here only. I am starting from here. Even though other direction may carry more number of carbons, don't follow that rule. Means when second rule is present, don't apply first rule. Apply blindly second rule. So means that's why aldehyde, ketone, ester, acids, when these functional groups are present, always this carbon should carry 1. Start from here, don't start from here. Then, numbering of a longest chain. So, parent chain numbering depends upon the substitutions, locands or groups. Always select a direction. See, if there is no substitution, start from anywhere. If any substitution is present, select a direction of parent chain where substitution carry lowest number. That is very easiest one. Then go through this lowest sum rule. So when more than one substitutions are present, we need to apply this one. First point of difference rule is also there. That you need to apply. What is lowest sum rule is saying? Select a parent chain such a way that sum of two positions of locand should carry lowest number. If I select from right to left, left to right. So both directions, sum of these positions are 5 and 7. 5 is lower than 7, so that's why I'm selecting right side. All are same. If different substitutions are present, if sum of locands are same, on the time follow the substitution starting alphabet. Means I am following alphabetical order. But when substituents are different and giving a two different positions, follow lowest sum rule. These two be careful. And unsaturation rule is saying that try to insert maximum number of unsaturated double bonds or triple bonds in parent chain. If any substitution is present, consider only carbon double bond but not substitution. Here also, if multiple double bonds are present, use letter A. If double bond triple bond is present, numbering start with double bond and end with triple bond. Iupac name end with triple bond. Suppose if double bond triple bond both are present, whichever is terminal, we need to give numbering from the terminal unsaturated functional group only. Here triple bond is a terminal starting from triple bond. Here double bond is a terminal. I am starting with double bond. Now here also same. So multiple unsaturated skeletons are given. I selected based on the priority rules. If rings are present, end with cycloalkane, cyclohexane like that. When substitution is present, only one substitution, no need to give numbering. Write down directly methyl cyclohexane or one methyl cyclohexane, both are same. If you write this methyl here and anywhere else, molecule name is methyl cyclohexane only. If more than one substitution, numbering is mandatory. Okay, this is very important one. So when double bond and any substitution is present, first you need to give priority for double bond with lowest number. If double bond with lowest number is completed with any substitution, double bond with lowest number, substitution with lowest number also priority. We need to follow. Okay, so this is in examples. This is most expected in your examinations. Regularly they are asking. According to branching rule, if any substitution carry additional substitutions, they are called branches. So simple branches is this one, and long chain branches will be there. Long chain branches means it is further connected. So always try to reduce branches and increase substitutions. If more than identical branches are present, bis, tris, tetrachis words will be applicable. Okay, this is the general applications of these two. Okay, so here two identical branches, that's why I'm using bis. These two are not identical, that's why I'm writing separately. Okay, so that is end of Iupac rules. So hope you people understand this concept, and this concept will be most helpful for variable organic molecules, Iupac nomenclature, so that you can give Iupac nomenclature clearly. So practice this all, and if you practice this, then only your next class will be easy to understand. Okay, so thank you for watching.